All right, we're on Fawkes. It's the last one of the Harry Potter series, except for I think there's one that doesn't really fall within the series, but still a Harry Potter type box, but doesn't fall within that series. Let's go ahead and scan him, and he's resigning at 48. All right, so we got 21, 22, 2222, 9898. So let's go ahead and try FTP in this guy. Okay, for some reason it just froze. What the hell? Oh, probably because I already copied that. I'm like, wait, what the hell is this? Okay, let's go ahead and FTP in this guy, see if we get anything. Oh, I think we actually did start this one. Then we realized that it was, yep. So let me go ahead and actually LS Tech LA this guy. And yep, we believe it's going to be a buffer overflow. Because if I go ahead and run this, then I do a little something like this. And then that's like where we stopped at. Was like where we thought, okay, cool, it's a Linux buffer overflow. Unless it just broke. Okay. That's kind of strange. Because before we were getting something actually out of there. So thought we figured out it was supposed to be a buffer overflow. Maybe we didn't actually. Peer/server. Okay. Does that open up a port on myself? It does. Notice that 9898 all of a sudden opened. So let's go ahead and netcat into .9898 because that was one of the ports that they had, right? Okay, so we didn't get a segment fall on that one, but we did break the port, it seems like. Okay. We also have to go a lot farther with also. Okay, it looks like we just broke that guy. This may actually not be the best one to do because I feel like we're going to have to like close out of him every single time we do something. Unless if we could just actually and then just hold this down for about a minute and see if we get a buffer overflow here. Expelliarmus. Alohomora. Somebody in the chat can say it's Alohomora, not Alohomora. Or however it goes. Okay, so we do. We get a segmentation fault over here. Okay, cool. So we most likely think it is actually MSF banner create, right? Why am I having such a hard time with this thing right now with MSF banner create? Why am I? We also need to actually, we actually need to take down the ALSR like real quick too, and that should be in randomized VA space. Shit. We have to find that. I believe that's in Etsy somewhere, isn't it? Or is it in proc? Oh, we have to echo a 0 somewhere. There you go, thank you. Alright, cool. There we go. Okay, now ASLR is now shut off, okay? So let's go ahead and start up our Python script, right? We might actually do an MSF pattern create first, just so we can try to figure out. Well, we do need to know right where it's actually having a problem now, don't we? Um, so let's go ahead and actually start up our um, Python shell first. So we'll start off with a Sublime. awks.py. Okay. Go exit out of all this stuff. Okay, cool. Now we are doing Linux buffer overflow. Okay, so that's a little bit different. Okay, there we go. So the very first thing we need to do is we need to connect, right? So we need to import socket. We're gonna need to connect to something, right? So we're gonna need to connect, right? So since we have so we should be doing a shellcode equals, and we should be sending our A's, right? So we can say A times 2000. Okay, A times 2000. We'll send 2000 A's at it, and we'll see what's going on from there, right? Then we'll do our S equals socket connect, right? Socket. Fuck it. We need to initiate it, and then we need to stream it. Socket. Initiate socket.af stream. Is that how it goes again? Do you remember? Sock stream. Is that it? Then we need to connect to the client. And that's on, what port was that again? 9898. Okay, there we go. So now we're connect to ourselves right on 9898, and then we're going to send off that shellcode, right? That A times 2000, right? And then we're just going to close it out from there. Whoops. Okay. So why don't you give that a try? Perhaps forgot a comma. I don't feel like I didn't forget a comma. I think I actually just put too many of those guys in there. That's not connect. No, it's definitely a comma like right there. Okay. Well, syntax professor got a comma because probably because I need I see because I would have because it's a float to according to it, right? Second one argument two are given. Yeah, because I didn't. Now I don't have the double brackets, huh? Killing me. Kill me, Smalls. Okay. A bytes like object now is required, not string. I'll do something like that, like right there. Definitely closed it out though. Can I do that like right there? This fucker. That should. What if we do a? If we actually just give it the 41, so we do something like this. Oh, BA should actually work, right? What is this vile stream? What do you mean? Alright, so that works like right there. At least connects. Okay, cool. Illegal? It's not illegal. That was a good try, though. Okay. So we have that now, right? We're not getting the segmentation fault, though. So let's go ahead and up it to like 3,000 or something like that. See if we can get a segmentation fault here. Or is it because it's always setting up just 1A? Is that what's happening like right now? Illegal. Equals V times 3,000, right? That should work just fine, like right there. I wonder, because we definitely didn't put 3,000 A's in before, right? Okay. Yeah, we definitely did not put in. So let's try with the actual bytes. Okay, that's an A. 41 is a capital A, like right there. Still not getting a segmentation fault. Okay. Huh. Now I'm wondering why we're not getting anything back there. It's very, 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 very strange. Because we're not getting that segmentation fault anymore. And we did before with it, right? Okay. Gotta figure that out, like right there. Something's going on with like right there. Socket, socket, AFINET, socket, sock stream. CKT.sock stream. That looks good. It's going to connect. It's 9898. That all looks good. It's going to send out the shell code. That's going to close. That all looks pretty good. And we're getting this from over here. A bytes like object. Required, not string. We definitely did not send. We might be sending too many. I wonder if we're sending actually just too many. Let's go ahead and bring it down to like 500 because we did not send that much stuff to add it. You know what I'm saying? Nothing. I don't think it's actually sending that like right there. It should connect. Send. That shouldn't be a problem like right there. I don't understand why that's a problem like right there. That shouldn't do anything at all. Well, at least it is actually connected. Okay, that's super, super strange of why we're not getting a segmentation fault anymore. Okay, let's just see if it's because it's still crashing it. The program's still crashing, right? So let's go ahead and let's see if we're actually overwriting stuff, right? So let's go ahead and use GDB. Okay. From here, we're going to have to run it. Okay. Okay. It doesn't look like we crashed it. Okay. Now we should be able to see the. Is this still? We should be able to see a lot more than that. Huh. Yeah, that's not a bad idea. Actually, just print it, see what it's actually doing, like right there. So, okay, it's sending that B up also, that's why. It's sending that guy up too. Why is it saying that? Why are we having so many problems with that, like right there? So there you go. So it is printing off 500 A's, but why? It doesn't. That doesn't matter. We can take that away and still can save that thing. Um, do I have to encode it? Never. Well, I've also never written in Python 3 actually before. Let's try Python 2 because I must say I've actually never written in Python 3 also. So we can get rid of print like that. Yeah, this should still be like that. That should be the only thing that changes for this whole thing. Is that print, I believe, between Python. Oops. Okay, so that, okay, there we go. So Python 2, we got just fine. All right, so we get our 414141441. That should be in the EIP. All right, we see that crash like right there. We don't know if it's the EIP yet, but from here, let's go ahead. So we got 500, right? MSF pattern create. All right, was it TAC L, right? For length, right? So let's just say length of 500. And there we go. So now we'll go ahead and we'll throw this into there, and then we'll see like where the offset's at. So we'll go ahead and we'll say our shell code is now going to be that, right? And we'll go ahead and we'll do it again. Okay, so there's our offset like right there, right? So we'll just go ahead and say MSF pattern offset. TAC L was 500, right? So if we do a TAC H, right, our length was 500. And then our query is that like right there, right? That's great. Do I not need a 0x in there? No, definitely do. It was indeed at 500, right? Okay. Doesn't look like it actually crashed now, does it? Okay. All right, let's do 1000 then. Save that. Okay. Okay, 112 is the exact offset. All right, so now we know we need 112 A's and then 4 B's, right? So we say A times 112, then we say offset. Then we say, we could always just say, we call this offset now. Then we're just going to say, then we can say that we want to add in 4 B's, right? So we're just going to do, so we found the offset now. So now we just need to control the IP value. So we should just be able to say plus B times 4, right? Or we just say plus BVBV. We'll just change it back to shellcode so I don't change everything. Right. Okay, let's go ahead and see if that works like right there. Okay, 42424242. Good. So now we know we got our 4 B's in there, right? So now we know that. Okay. So now we know we control the EIP, right? And we know that's 4 B's now, right? So now we need to actually, we found the offset, right? Because it's pretty much we need to find the jump point now, right? Huh. With Linux, I've never really done this with Linux before. I've done it with Windows a lot. I have a whole thing on Windows in this. But Linux, haven't really done too much with it. So we now need to find a jump point, which I feel like we can find this pretty easily. Okay, I believe we can run. Okay, do we not have EDB on here? EDB debugger, there we go. Yeah, we did a couple other things, Marto, and now we're on a buffer overflow. It's like the 4th box today. Okay, so we want to attach. What the hell is it called again? What the hell is this thing called? Server Hogwarts, there we go. Okay. Alright, that's good. Let's go and quit out here, and then we'll try to attach again. Can I just type it in? Damn. Oh, attack attach. That'd be sweet. Failed to attach, those are process. Good. That's good. Can we just run it? Can we open it? How about that? Okay, we can open it. Okay, cool. So, yeah, I got buffer overflows. I have a whole series on YouTube. Let me see here. Let me grab like real quick. For Windows. For Windows, I do. Not too much with Linux. By not too much, I mean like none. I don't think. Or if I do, then they're super simple ones. Let me go ahead and go into content. Let me see here. Playlist. I'll get the link for the buffer overflows for those ones. Where did I put them all? Oh. Let me go ahead and drop this in the chat. There you go. There's the YouTube buffer overflow playlist, like right there. Okay. So now we need to find a jump point, right? But we got to find a jump point in Linux now. So we know that we can control the EIP. Okay. Now I know that we can utilize opcode to find a jump point. Okay, so we want to, okay, cool. So we could read and write, and we could read and execute. I believe we want the read and execute one. And we want to jump between the ESP and EIP. That would make sense to me, right? Since that's kind of what we're controlling, right? Find. Okay, so there's our jump, like right there. That's our jump point, like right there. Let's go ahead and, can we copy that? Okay. Hey, anytime, man. Thank you. So let's go ahead and put that into here. Okay, our jump point, like right here, right? So we have, does anyone know if I have to do, I don't think we have little Indian, do we? Format for this kind of stuff, right? For Linux, does anyone know? Okay, so we got that, right? We now have a jump point, so we can put that actually into our Python script, right? I don't know if it does little endian. Actually, now I think about it, I don't see why it wouldn't actually. It should actually do little endian, right? So let's say JMP equals, and little endian is going to be, so little endian is actually going to be slash 55 slash x 55 slash x, or is it the other way? No, it's definitely that way. 55 slash x 9d slash x 04 slash x 08. That should be the little endian format of it all, right? Whoops. Man, DZ64 we could use like right now. Okay. So that should be our slashes. Those slashes are not going the right way because it should have fucking shown up as, yep, it should show up like that. There. That's how it should look like right there. That should be our shellcode like right there. Okay. So now what we want to do is have our shellcode. Get rid of this. So we want to send shellcode. Now we actually are going to need 2 brackets around this guy because we're going to call for more stuff. Shellcode to the jump to a slide right. So we'll call it slide. X90 times, I don't know, 30 maybe. We'll do something like that. To the slide right. So we can slide it into the exploit. Then finally to an exploit, which should technically get us a reverse shell on myself, right? And then we're going to have the actual buffer. And that's going to equal the actual MSF Venom payload that we're going to make, right? So we'll make an MSF Venom payload that is going after Linux, right? That's how we want it, right? And it's an x86. It's only 4 bits per, right? So we know it's an x86, so that's not going to be a problem, okay? We don't know about any bad bytes. I don't even know how to even look that up in Linux. I don't think they really have bad bytes. So we'll do MSF Venom x86 slash shell. Should be like that, right? Linux, actually it's a shell. Attack P. Linux x86 shell reverse TCP, right? I guess we'll just try to set it all at once, okay? lhost equals 192 myself, right? 168.0.26. lport equals, I don't know, 4444, okay? There's no bad bytes except for most likely 00. So tac B, right, for the bad bytes, right? Tac B x00, right? And then we'll say, we'll go ahead and we'll output that into C. Let's try that first. Or we could output it into Pi for Python, right? I think I only need right to there. Buffer should be like that, okay? Then all we're going to do is that to there. Okay, slide to buffer. Okay. Now we can go ahead and we can set it off. Does it go to work? I don't think so. But no point not trying. Let's go ahead and see if I get a reverse shell. Oh, that's definitely not going to work. Okay. What are we supposed to use? Trigger buffer, not tuple. Did I? Oh, you know why? Because of all that, like right there. So we actually just want to make this, we'll say payload. Payload equals, and payload's actually equal all that stuff. That's just going to send. Yeah, payload's actually just going to equal all this. I actually don't know if I actually need a double around there. And then we're actually just going to send payload. I think we should be able to do it like that. I think we can. Okay. Okay. So it's still, say, line 19. Huh. Yeah, we have a jump, ESP. We used EDB to grab the jump. Okay, so we got our jump. We have our okay, so our payload is going to equal shellcode plus the jump, then the slide into the buffer overflow, right? If I remove that, then this is a C, not a Python one. If I remove that, then it won't look at it as one. Unless we do a Python one. So you're saying I need to do something like this? Nope. I will say I never had to do that before. That one like right there. So that target must be stringer buffer, not a tuple. It's not a tuple. Okay. You know what? I got a better idea. Here. Oh, wait. What if we do something like this? Nope. Okay. Let's go ahead and I got another idea. We're gonna do that plus You know why? Because it's all commas, isn't it? That's why. Because I put in commas, huh? And I should have put in plus signs, huh? It should be shell code plus jump plus, that's why it thinks it's tuple, okay. Plus buffer. Yeah, plus, yeah. Yeah, plus. I just realized that too. Okay. And we do actually get a reverse shell. I did not see that coming. Okay, let's go ahead and restart the machine because I already broke freaking the machine the first second I had it. So go ahead and we'll start it and we will fire it back up again. And all we should have to do now is just technically change the IP address. And we should get a reverse shell. Hopefully hopefully you know, hopefully we get a, what is it? Excuse me, I'll get there one day. Root reverse shell, like immediately. We won't, but okay, so it's living at 48, right? So we want to go ahead and change this to 192.168.0.48, correct? Okay, let's go ahead and make sure that port's actually open and listening. 9898 is open and listening. Okay. And let's go ahead and send this guy off now. And we do have our listener down here. Let's see if we get a call back. 489898 said no. Okay. Do I have to connect to it first? And it's still connection refused. Did I break it? Did I like totally break it? And now even restarting it, I can't. Do I have to like re-download it? When I rust scan it, is it still open? Oh, I just broke the fucking machine, that's all. I think I actually broke it. Let's make sure that's where it's actually residing at. Yeah, I broke the whole machine. That's all that happened. Okay. 9898 is working. I think I just broke the whole thing, in all honesty. So does that mean I'm gonna have to, I think that means I'm probably gonna have to re-download it, huh? Great. Okay. Well, this means I'm gonna have to re-download the actual box, I think. Because I just restarted on my side. Let's try one more time. We'll reset it one more time. And we'll try one more time. See if we could get it. Let's go ahead and throw okay, so we know this does work. Okay? So we know that does work, right? Okay, there we go. We got a reverse shell. So reset it worked. Oh my god, are you serious? We're not even freaking. I hate you. Okay. Let's go ahead and get a reverse shell. Let's go ahead and get reverse shell if we know it's going to work. Since sometimes. Okay, so for some reason, we're in a fucking Docker. So we're just going to go for it then. What I'm scared of is that if I grab this and do it, then it's going to break it again. Okay, well, we sit there and break it. So we are in a Docker link right now. There's our Docker environment link right there. We if config. we can see, 1 second. We can see that we are in a Docker, right? So 172.17.01 is most likely our way out of this Docker. Now we just got to figure out where to go from here. All right. Let's try to figure out how the hell we get out of this guy. Okay, so okay, at least we have some creds here. Can we run sudo in the Docker? We can. Oh, no password, no password. So we should just be able to get out of the Docker then, right? Um, Jesus Christ. There we go. Okay, hello, and we found that someone's trying to log into our FTP server by mistake and requested to analyze traffic to figure out the user. Okay, so we should be able to do it with TCP dump, right? So we just need to actually look at FTP, right? On ethernet 0. We probably have to run sudo with that. TCP dump. Tag I ethernet 0. And we want to look at FTP, right? Damn. Okay. TCP dump. Should be FTP, shouldn't it? Or the old ones used to have to do attack port, right? So does this need attack port in it? I'm wondering. So we have to do attack I ethernet 0 port FTP. Yeah, okay. So I guess we'll just analyze this traffic. See if we get anything. We also actually may need to do FTP data. And I should have only done it for so long, and now we're going to kind of be screwed, huh? Because now I'm stuck in there. God damn it. Now we have to reset the box, don't we? We're going to have to reset the box. Alright. DZ, we could have used you. We just did Linux buffer overflow. Okay, so we can do a sudo TCP dump. Actually, I don't even need to run sudo anymore because I have root. So TCP from scratch, yes sir. TCP dump, tac I, ethernet 0, port, or tac C. We'll go with like 30. Port, TCP, port FTP, and I think you can do an AND, right? Port FTP or FTP data. Okay, let's try that like right there. Let's see if this is actually working also. FTP, oh, yeah, it's working. Okay, we're getting something. We're getting somewhere. See anything? Nothing yet. Still nothing. But yeah, there's our sweet buffer overflow. We'll actually send over that it? Oh, user Novell. Pass. Oh wow, that was fucking pure luck. Alright, cool. So we got a user and a pass. Let's go and try SSH as that person. I wonder if the port's actually 2222, because you know we had that on there. Oh, 168, my fault. Damn it. Where the hell is password? Right there. Okay, cool. So we're now Neville. Or Neville. It's Neville, I know. Bloop. It's in C. And Python 2. And that did say print the actual payload itself, but you can go ahead and get rid of that now. But yeah, we did it. We use EDB and GDB and everything. No, no. Okay, let's see if we're still in this Docker or not. I don't think I am. I'd be really surprised if I am. No, I'm not. Okay, good. So we're not in the Docker anymore. Well, obviously we did 192.1 state. All right, cool. Let's go ahead and SUID lookup. We can't do sudo with him, right? There's our FTP share, our Docker container, automate FTP login.sh. Okay. Okay. Let's go ahead and okay. So now we just need to see what the hell's next. Let's go ahead and cd into temp. Jesus. There we go. I thought that would have worked. Oh, I guess it's just a pipe bash, huh? Looks like it's actually vulnerable to a couple kernel exploits. So ptrace, this guy like right here. I had a Polka one. I think I actually have that. I have to actually check. So right now we're still looking at that kernel exploit. This is the back one though. Should probably take a look at that though. Why is that right up by everybody? I see password out back. That's not make it matter. Yeah, because that's not. We can't just delete that or anything like that. Oh, okay, that's why. All right. Let's go ahead and let's try that poll kit. Ptrace Ruby 1. There's the C like right there. Don't know exactly which one we need. Pseudo version was also on day 2, so I don't know if we can do something with that. It was, yeah, we saw that was out of date up there, so. Um, okay, so that one's the not root one, right? But we can't even run sudo on here, right? What was his password again? Yeah, he can't run sudo. So that's not going to be very helpful now, is it? Um, so I'm thinking the poll kit one. It was poll kit, right? It was poll kit or ptrace me? Ptrace me, never mind. Okay. Okay. Kernel 4.15. So this way right here. I believe, at least. That's what I think it's going to be. .15. Okay. Where's the GCC for this thing? Okay. Okay, let's go on wget. Go on wget this like real quick. Got 5. Damn. Okay. Guess that one ain't it, huh? Okay. 4.19.016. Yeah, I guess so. Okay. So we're looking for another ptrace me, huh? So let's go ahead and just grab this like right here. We'll say ptrace. That's the one that we just did, isn't it? Like right there. Let's see. Find out. 47163. Yeah, that's the one that we just did. But that one did not work. So I believe that's CVE 413272. Okay. Doesn't seem to like this one though, like right here, that does it. You know, I did GCC it over on my machine though, did I? Probably should not have done that, huh? No, I GCC'd it over here, never mind. Let's go ahead and actually grab this one like right here. See if this is going to do anything different. Oh, it's not going too bad. How you doing, Justy Guy? Everything's going pretty good today. Oops. Give that a try. Okay. So still nothing with that. Gonna say that thing. Check environment. Cannot find PKEXEC. So it doesn't have it. Okay. Oh, hey, Christy, how you doing? This is on VulnHub. It's Fawkes, Fawkes, one of the Harry Potter boxes. Um, hmm. Where was that damn? We can only, okay, not that one. We can only read this guy right here, can't we? Yeah, we know that, like right there. It won't work for this one because that's the not sudo, the exclamation point sudo one. The 1.827 is that one, like right there. That one's the not sudo one. So I'm just trying to figure out. I'm pretty sure it's going to be something with this PK or this ptrace because I've had that one give me problems before and then work, you know? It's just which one is it? So, okay. But I'm pretty sure there's a. Not that one. Yeah, this guy. Let's try this. One 1.827. We're not on that though, like right there. It's the same one? Yeah, okay. We can throw it at it, see what happens, see if it sticks. I don't think that one's it. Wait. Is this one the hack me a sandwich one again? No, this was the hack me a sandwich, right? Is that this one like right here? Yep, it is. Let's see here. Someone else will just... Hey, thanks a lot, Trevids 101 for the follow. Thank you very much. Okay, I think I know what to do here. I'm going to do wget R for hack me a sandwich. God damn it. Not what I wanted. There we go. And it should be on 0. Nope. 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 Nothing there. Oh, no, I've never taken OCP. No, I will not stop, DZ. That is the actual, that is the same exact thing. Because there's the hack C like right there. Which sudo edit? KDZ, you win this time. What would it be in? You win this time, DZ. I'll let you take this one. Use your local bin sudo edit. Local bin sudo edit. Is that the only place that that happens? Okay. Alright, cool. That's actually... Yep, okay. There's that. Let's make sure that libc looks good too. Thank you, DZ. Good thinking. Should be in here, right? That should be good. So you're gonna hack me a sandwich again, right? Oh, look at Blue Ninja. How you doing? Still nothing. Still nothing. Jesus Christ Almighty. Hey, look at Blue Ninja. Thanks a lot for the subscription. Thank you very much. Still nothing. What? Use your local bin sudo edit, right? Use your local bin sudo edit. Is there like a different, is there also like a sudo path in here too? Is that going to be different also for no apparent reason? And it's vulnerable, but it's not doing anything. It should, from here, we should get a shell back, like right there. No, brute doesn't do anything. See, seeing if you can get the segmentation fault. Pretty much that's what brute's doing. Um, wait, where's that Python one that we had? That's proof of concept. I wonder if it's there. I wonder if that's what that guy's problem is. No, that one's just not even on the machine. Hold up. So there was also a Python one of these. And I wonder if that one will work with it. Some stupid shit like that. I don't think it's that. I don't think it's user spec. No, that's the one that we just did. We could try this like right here, but we're really surprised that one works like right here. That's all my W get. That's all I want. Offset. Yeah, I modified it. It was modified. This one, like right here, this one doesn't have anything in it. Ready? Watch. There it is. Okay, I see what I want. Okay, cool. All right. There. There. We did it. Don't know what it did, but we did it. Voldemort defeated by Harry Potter. You are welcome. Well, that was one of those just yeet. Ah. Machine difficulty hard. I was hard. Not really hard, but more of like a medium. See how long it took. Hour 12 minutes, a medium.